Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 6th, 2025. So, just yesterday. This paper shows how a new framework can teach an AI to use unfamiliar software, boosting its success rate from 11.3% all the way to 34.5%. The paper is titled SEAgent, Self-Evolving Computer Use Agent with Autonomous Learning from Experience, and the approach is really quite clever. It tackles a big challenge for what are called computer use agents, which are AIs designed to operate software just like a person would, but they often struggle without human guidance. Also, the authors shared their official implementation on GitHub, and it's a great resource for anyone wanting to try this out. You'll find setup instructions, scripts for training and inference, and even the code for evaluating the agent on different benchmarks. On Hugging Face, you can find the SEAgent models, including the 8 billion parameter agent and the world state model, available for you to download and try. So this diagram gives a great overview of how the whole system works. At the top, we see the agent's learning cycle for a single piece of software. It starts out not knowing what to do, but through a process of trial and error, where it gets feedback on its actions, it becomes a specialist. Then, the bottom half shows the core strategy. Instead of trying to make one agent learn everything at once, they first train individual specialist agents for each program. These specialists are then combined to create a much more capable generalist agent. Alright, so let's dig into the details of this learning pipeline. The process starts with the main agent, called the actor, taking an action in the software. This whole sequence of actions is then evaluated by a really smart component, the world state model. It looks at everything the actor did and provides a step-by-step judgment, basically a thumbs up or thumbs down for each action. This detailed feedback is key. Successful actions are reinforced using a method called group relative policy optimization, while failures are penalized, helping the agent learn what not to do. This table then shows just how well that world state model performs, benchmarking it against others like GPT-4o. The key insight is how models react to seeing the entire process versus just the last screenshot. The author's world state model, especially the final version, shows strong precision, meaning it's very accurate when judging a task successful. It closes the gap with GPT-4o and significantly outperforms other open models, which surprisingly get worse when shown the full sequence of actions. Moving to the results, this table shows the success rate across 5 different programs. The baseline model, UI TARS 7 BDPO, starts with an overall success rate of just 11.3%. But after applying the full framework, the final SEAgent, using that specialist to generalist strategy, achieves a 34.5% success rate. This is a huge leap, and it even outperforms an ensemble of the individual specialist agents, really validating the whole approach. So, to wrap up, this self-evolving framework is a really promising step towards more autonomous agents. The combination of that clever specialist to generalist training strategy and the detailed feedback from the world state model clearly makes a huge difference. That's it for this episode of the